quick appendix for the lecture notes on identifying creep failures. Here I have a creep failure in high purity tin wire, which can creep at room temperature. This failure shows a lot of necking. It shows an extreme amount of necking, which we associate with ductile failures. So this is a very ductile failure in a very ductile material. And so on the macro scale, let's just pretend I wrote the word scale there, right? Okay, there we go. Macro scale, very ductile, lots of plastic strain. But now let's consider the microstructure. We have grains. Right, so this isn't the greatest grains, but they start to separate. Right, so we get these separations. And so when our material comes apart, there we go, and we will have failure here. Our material is separating. Okay, that means that we are outlining our grain boundaries because of how the grain boundaries are the sites for failure and creep, which means, what does this look like on the micro scale? Go back to when we talked about tensile failures, and look at intergranular, which is associated with brittle failures. So here's a situation where on the large scale it looks like we have a ductile failure, but if we were looking at it just under a microscope, we would assume it was a brittle failure. The mixture of those two different and seemingly opposite modes of failure and ways of identifying a failure are indicators that this is definitely a creep failure, specifically when we see this. Not brittle on the big scale and ductile on the micro scale. Specifically, ductile on the macro and brittle on the micro, because of the way in which a creep failure occurs. So we'll get grain deformation, and we'll get the grain boundaries coming apart, sliding next to each other. Finally, they separate. So that creates, again, a ductile on the macro scale and brittle on the micro scale.